Welcome. In this video, I am going to demonstrate how to locate the critical points of this function here of two variables. So the first thing we want to do is compute the partial derivatives with respect to x and with respect to y. So the partial derivative with respect to x is going to be 1/2 times the derivative of this outer function, that is this square root function. So we'll have all of the inside here to the negative 1/2 power. And then to that, we multiply the derivative of this inner portion with respect to x. So that's 10x minus 30. So the partial function, that is the partial derivative with respect to x of g, is equal to 10x minus 30 divided by 2 times the square root of 5x squared minus 4y minus 30x. Excuse me, that's a 4y squared. Plus 8y plus 21. And now I'm going to rearrange just a tad and compute the partial with respect to y. So again, we're going to have the 1/2, this whole radical to the negative 1/2 power now. And then we're going to multiply by the derivative of this inner function with respect to y. So that's minus 8y plus 8. And if you don't see how I'm obtaining these, please pause your video and try this independently. So this yields negative 8y plus 8 divided by 2 times the square root of 5x squared plus 4y squared minus 30x plus 8y plus 21. And then both of these can be simplified a little further as we have even terms in the numerator and a 2 in the denominator. So the partial with respect to x is equal to 5x minus 15 divided by, oops, no more 2 there, the square root of 5x squared minus 4y squared, and so on. So the idea is to set both partial derivatives equal to 0 to identify the critical points, sometimes called critical values. And really, just like in algebra, calculus, whenever you did this, all that matters is the numerator, since when you multiply by the denominator on both sides, it'll vanish. So really, what we're left to solve is 5x minus 15 equals 0, and 4 minus 4y is equal to 0. So we end up with x equals 3 and y equals 1. This yields the critical value of, excuse me, not x, 3 comma 1. So that's one of our critical points. Okay, so we also have to look at the places where the partial derivative is not defined. And both of these have the same denominator. And when this denominator is equal to 0, both partial derivatives will be undefined. Also, when this value, this equation polynomial here inside the radical is less than 0, both of these will be undefined. So what we need in this case, we need 5x squared minus 4y squared minus 30x plus 8y plus 21. We need that to be greater than or equal to 1. Now, what does this actually look like? And I asked what it looks like since any point that lies on this curve specifically is on the boundary of our curve. That's the boundary of the domain, I mean. So let's complete the square a couple times to figure out what this looks like. So I'm going to rewrite this as 5 times x squared minus 6x, and I'll leave a space there, minus 4y squared minus 2y, and again I'll leave another space, greater than or equal to, or actually let's just do equal, let's just focus on completing the square, is equal to negative 21. And since I'm running out of space, bear with me a moment while I add some space down below. So in order to complete the square, I'm going to have to add a 9 here, and I'll do that in a different color. There we are. And I'm going to have to add a 1 here. Now that I've added 9 here and added 1 here, I've unbalanced the scale. That is, if you consider your equality. Oops, this is me trying to draw a scale. Like a scale, I've unbalanced it. It's heavier here, so I need to go ahead and add the same values to this side. But rather than just add 9 here, I need to add 5 times 9 here. So that's plus 45. And then I'm not just going to add a 1 to this side, I'm going to add a negative 4 times 1, so that's negative 4 to this side. So we end up with 5 times x minus 3 squared minus 4 times y minus 1 squared is equal to 20. So remember, the whole point of completing the square twice is to rewrite this to see, what shape, what surface this is in 3 space. And I can do one last thing, that is divide both sides by 5 times 4, which is 20, to end up with x minus 3 squared over 4 minus y minus 1 squared over 5 equals 1. So this boundary of the domain is a hyperbola. And now it is in standard form. Okay, so let's go ahead and summarize our result. That is what we came up with, and as usual, I'm going to make a little space for it here. So what we came up with is the critical points of G are equal to 3, 1, and all points lying on the hyperbola x minus 3 squared over 4 minus y minus 1 squared over 5 equals 1. So those are all our critical values for G. Okay, remember to keep calm and math on.